Chapter 3 is going to deal with matter, and this is a topic that you've covered before in middle school science. This is a quick chapter that's going to cover things you're very familiar with. We're going to start with the definition of matter and talk about physical and chemical properties and changes as well today. So by definition, and if I ask you what matter was, I'm sure you could come up with this. So it's anything that occupies space and has mass. And we know that it exists in 3 states, and solid, liquid, and gas are those states. We'll talk about plasma at a later time. But the solid, if you notice the molecules in the solid, they're very close together. The liquid, there's more room between them, and in the gas, there's even more space between the molecules. And we'll talk about why those make solid, liquids, and gases, and what the distance between the molecules has to do with it. So here is a picture of ice in a flask, of liquid water in a flask, and of gas in a flask. So the solid, the water molecules are locked in this position, and it's due to the polarity of water. And you'll notice that this is a structure that is almost crystalline in nature, that it looks like from looking at this picture, and that these hydrogens are attracted to the oxygens of the other neighboring molecules of water. Now this solid is still in movement. I know the structure makes it look like there's no way that that's moving, but they are in movement all the time. All molecules are, even in the solid form. When we look at liquid water, you'll notice that they're not as connected, that there's distance between the hydrogens and oxygens of the neighboring molecules, and that allows the flow to happen with liquid water. And then gas and steam has a much higher kinetic energy. You'll notice the space between them is much more, and the energy is much more, and that allows it to be in gaseous form. So you know, because you're familiar with this, that a solid is rigid. It has a fixed volume and shape, and an ice cube, a diamond, an iron bar, those are examples of solids. And I know this seems very elementary, so it'll just be a quick review. We know that liquids have a definite volume, but they don't have a specific shape because they're going to take the shape of the containers. So gasoline, water, ethyl alcohol, blood, those are all liquids, and they take the shape of their container. While they are all liquids, you notice that they have different levels of viscosity. Some are thicker or thinner than others, and we'll talk about that in a later chapter as well. And this just shows that liquid is going to take the shape of whatever container it's in. Gases have no fixed volume or shape. It takes the shape and volume of its container, not just the shape of its container. Air, helium, and oxygen are examples of gases. We're going to talk about physical and chemical properties and changes in section 3.2. Physical properties are the characteristics of matter that can be changed without changing the composition. And we saw this in lab with the gallium. And this is an example of gallium in the hand here, how it was solid, but if you warmed it up just a little bit higher than room temperature, it became liquid. So that is a characteristic that can be changed, but it does not change the composition. It was still gallium, whether we heated it up or not. They are directly observable characteristics. So if I say it smells like this, or this is the color, or the volume reads as this, whatever state it's in, the density of it, the melting point, the boiling point, those are physical properties of chemicals and matter that are around you. So you need to keep those in mind. Basically, what can you observe with your senses and be able to explain that? That's a physical property of that chemical, particular chemical or substance. Chemical properties are different than physical properties. A substance's ability to form a new substance is what a chemical property is. And the characteristics that determine how the composition of matter changes as a result of contact with other matter or the influence of energy. The characteristic that describes the behavior of matter. These first 3 bullets all explain what chemical properties are. Now let's look at some examples. Whether a substance is flammable or not, that is a chemical property. The rusting of steel is a chemical property of iron. The digestion of food is a chemical property of the substances inside your stomach working with the enzymes inside of your body. So the chemical properties is its ability to form a new substance. If you keep that in mind, that will help you to keep the chemical properties and the physical properties separated. Let's look at a concept check. Classify each of the following as a physical or a chemical property. Ethyl alcohol boiling at 78 degrees Celsius. That shows a physical property, and it's physical because that is a fact of ethyl alcohol. It boils at 78 degrees Celsius, so boiling point is a physical property. The hardness of a diamond, that also can be observed with your senses. That's a physical property. Sugar fermenting to form ethyl alcohol, however, is actually a chemical reaction, and that is a chemical property of sugar. Let's look at the difference between chemical and physical changes. A physical change is a change in the form of a substance, not its chemical composition. So we have boiling water here, we have ice here. We still have water, but both of them are in different states of matter. So it's a change in the form of a substance, not its composition. If we melt the ice, it becomes liquid water, and if we boil that, it becomes steam. In all three phases, the water molecules are still intact. We still have H2O, so the red is the oxygen and the white is the hydrogen. So red and white, red and white. The only thing, the difference between these three pictures is the distance between the molecules that changes them from a solid to a liquid to a gas. So a chemical change is different than a physical change. A given substance becomes a new substance or substances with different properties and different compositions. And an example of this is when you light your Bunsen burner in the lab, because the methane in this picture, but the natural gas that we use to light the Bunsen burner is a gas, and when we burn it, it becomes carbon dioxide and water, and it gives off heat as a byproduct, and that heat is what we use in the lab in order to carry out our chemical reactions in our experiments. This is the electrolysis of water. So we have water, and I like this picture a little bit better, but this is the drawing from your books. We have water, and we run electrodes into that water, and that splits the water molecules. So it goes from water molecules to hydrogen gas and to oxygen gas. And that is a chemical change because we have liquid water, which is H2O, together as a molecule, and we use electricity, the battery in this case, to split it into its components, which are hydrogen gas and oxygen gas. And oxygen and hydrogen react very differently than liquid water or even gaseous water does. So the water decomposes to hydrogen and oxygen gases. So this is what it would look like if we had water molecules. We run that electric current through it, and we end up with hydrogen gas, which is H2, and oxygen gas. So how many of the following are examples of a chemical change? And if you look at the one that they have circled, that's the only chemical change. It's the burning of wood. Once you burn wood, you can't get it back to the wood that it was before. It changes into totally different substances. Pulverizing or crushing rock, it's still the same. Rock salt is still the same salt when you get finished crushing it, no matter what physical form it's in. If you dissolve sugar in water, again, you can recover the sugar just by boiling off the water. And that dissolving of the sugar just surrounds the sugar by water molecules. It doesn't change the chemical composition of either one. Melting a popsicle on a warm summer day, there again we're changing states, which is also a physical change and not a chemical change. Let's look at another concept check. Classify each of the following as a physical or chemical change. Remember that a physical change is just going to be a change in the physical properties. A chemical change is actually going to change it to a new substance. So sugar fermenting to form ethyl alcohol is chemical because we're making something from something else. Iron, metal that's melting, it's going from a solid form to a liquid form, just like the gallium did. That's a physical change. And iron combining with oxygen to form rust, combining with, so it's a chemical reaction in this case because it forms a new substance, which is rust. That is a chemical change.